Hi everyone, here I am going to discuss about relationship between two variables. Step 1 is examine the relationship using a graph. Graph means scatter plot. Scatter plot shows the relationship between two quantitative variables. A point on the graph represents the combination of measurement for an individual observation. And step 2 is obtain a numerical value, that is correlation coefficient. Step 3 is fit a model to describe the relationship. Then we'll see types of relationships. According to the shape, we can describe the types of relationships. This is a linear relationship. You can see this plot and this graph as a line. There is no curve. And here, this is a non-linear relationship because you can see here there is a curve, not a line. Here there is a line, that is actually not a line. We can see these plots as a shape of a line. Therefore, according to shape, we can see the relationships as linear and non-linear. According to the direction, this is a positive correlation. And here there is no correlation. This is not positive or negative. There is no directly here negative correlation. If the graph has the line in this side, this is negative correlation and this is positive correlation, and here no correlation. According to the strength, we can describe the relationships. The first one is weak correlation. There is a space between two plots. It is a countable space. Therefore, we can identify this correlation as a weak correlation. Here, strong correlation. You can see the plots are very close to each other. And this is a perfect correlation. But we cannot get this correlation in the real world. Then we will talk about covariance of two variables x and y. Actually, covariance measures the linear relationship between two variables. This is the equation for covariance between x and y. Sigma xi minus x bar into yi minus y bar divided by n minus 1. Values of the covariance vary from minus infinity to plus infinity. And the correlation coefficient. Correlation coefficient measures the strength and direction of a linear relationship between two quantitative variables. When we talk about the correlation coefficient, we meet Karl Pearson's coefficient. When we talk about correlation coefficient, we meet Karl Pearson's coefficient. Later you will meet Spearman's correlation coefficient. But here I am going to discuss about Karl Pearson's coefficient of linear relationship, and we denote it as simple R. this is the equation for correlation coefficient. To find the correlation coefficient, we should know the value of the covariance between x and y, and also variance of x and variance of y. Here we are using the standard deviation value. After substituting the covariance of x and y and variance x and variance y, after substituting the particular equation to the covariance xy and variance x variance y, you can obtain this equation, and this r can be vary from -1 to +1. It is not like that the covariance. When we interpret the r or correlation coefficient, if r is equal to -1, we can say it's a perfect negative correlation. If r is in between -1 and 0, then there is a negative correlation. If r value is equal to 0, there is no correlation. If r value is in between 0 and +1, then we can say there is a positive correlation. And r is equal to 1, we can say there is a perfect positive correlation. Thank you very much. We'll see again with a new lesson.